I'm Bert Lagra. I'm Innovation Manager at the Center for Sustainable Catalysis and Engineering at the KU Leuven. The PROMIS project originated from a real need of Flemish companies to find a renewable alternative for the building blocks of polyurethane plastics. Polyurethane is a very versatile plastic. It's the basis of insulation materials, mattresses, the soles of our shoes, and is used nearly everywhere in our daily life. We investigate an alternative for the current isocyanate building block in polyurethane. Current isocyanates are made from fossil feedstock and result from processes that are not very sustainable, and they use currently very toxic chemicals to make such isocyanates. So Catalysti reached out to us at the knowledge institutions to apply for a strategic basic research project, which we did and which then ended up in PROMIS. Our alternative feedstock is plant biomass, preferably non-edible biomass, which we refine into intermediates that then will be further developed into new building blocks for polyurethane plastics. So in PROMIS, the target was on the one hand to find an alternative feedstock, which is biomass, on the other hand to make them in a much more sustainable way. The PROMIS project has 3 partners. We are coordinating it from the KU Leuven, and we work together with researchers from VITO and the University of Antwerp. So at KU Leuven, we have expertise to refine biomass into intermediate fractions, such as lignin oil and cellulose sugars. We use these to make aromatic building blocks that are then used by the University of Antwerp to make the renewable isocyanates.
At the organic synthesis team of the University of Antwerp, we are working on the synthesis of blocked isocyanates. Blocked isocyanates is a well-accepted industrial solution to overcome toxicity of the free isocyanates. However, there is still a problem. Blocked isocyanates still have to be made industrially from free isocyanates using the so-called blocking agents. In the PROMIS project, we are developing a completely new technology to make blocked isocyanates. For this, we use bio-based diamines delivered by other PROMIS partners and commercially available blocking agents. But of course, our methodology is also applicable to any other diamines such as currently used in the polyurethane industry.
So in the PROMIS project, the Sustainable Polymer Technology team of VITO is responsible for the development of new green isocyanates derived from bio-based molecules such as amino acids. Furthermore, we also have to be sure that these new molecules perform on par with the traditional fossil-derived molecules, and that's why VITO is also responsible for the design and synthesis of these materials, polyurethanes, and the material characterization, together with the evaluation of the toxicity of the new molecules.
Catalysti supported us, the academics, in the project administration and also formed the interface with the companies, which are currently all members of the advisory board of the project. In PROMIS, we will lay the basis for a portfolio of different isocyanate molecules, which we then can offer to industry to make a selection. With the selection, industry can go for further upscaling to eventually turn these molecules into novel polyurethane products.